Hello, and welcome to TechBytes.io. In this episode, we will get to know the common operators in Elixir. So let's get started. Elixir comes with all the normal comparison operators. You have your strict equality, your strict inequality, your value equality, value inequality, and then your normal greater than, equal to operators. Elixir allows you to compare values of different types, such as an integer and a floating point number. Comparisons use natural ordering if possible, otherwise the comparison works off of the sort order rule shown here. As you can see, it has order of precedence, obviously the highest being over here on this side, but with the binary. But as you can see, it goes number, atom, reference, function, port, PID, tuple, map, list, binary. So let's take a look at some examples. So let's roll over to our command line and open up IEX, or Interactive Elixir. So here let's get some space and let's take a look at some of our comparisons. So we can let's start with a string. So if we were to say a name and we do a strict equality of another string of name, you can see it turns out to be true. Let's do a strict equality of someone's name. And you can see that turns out to be false. So the two strings did not equal each other. I think the best way for us to review these, though, is probably with numbers. So let's do a strict equality of 10 equals 10. You can see that turns out to be true. But if we were to say 10 and not do the strict equality, do the value equality of 10 equals 10.0, just as I had mentioned earlier, Elixir allows you to compare different types. So you can see that 10 equal and 10.0 turn out to be true. But if we were to do the strict equality of 10 and 10.0, that would turn out to be false because the integer 10 does not equal the float of 10.0. You can see the same thing if we were to do this not equals. So if we do a strict, or let's not do a strict, let's just do an inequality, a value inequality of 10 and 10.0. You can see that's false because, just as we had mentioned before, you're able to compare the two. But if we were to do a strict inequality of 10 and 10.0, it would turn out to be true because the integer does not equal the float. So looking at let's look at the other comparisons, the general comparisons. We have let's see, 1 less than 5 is true, 5 is less than 3 is false. Now let's take a look at the ordering, just as we had talked about earlier. We have the, let's go ahead and bring that up. Oops. And here we have the default ordering of the different types of values in the precedent. So we see number is less than atom all the way up to binary, just as we had spoken about. So if we take an atom, let's do name, let's make that actually, let's get some room so you can see better. So if we do an atom of name and we say that is greater than 5, you can see that's true because the atom is greater than a number. We can reverse that to take a look. Let's see, name is less than 5 is false. But if we were to take this name and compare it against a tuple, so if we say this atom and we do a simple tuple of 1, 2, 3, you can see that is false because the atom right here, the tuple, is much greater, has greater precedence over that. Alright, so let's go ahead and move on. Alright, so let's talk about Boolean operators now. Here we have or, and not, so A or B, true if A is true, A and B, which is false if A is false, and not A. So the key words are or, and not that we would be using, and with not A, false if A is true. We can move on to relaxed Boolean operators, which allow us to use the pipes, the ands, and symbols, and the bang, or the exclamation point. So A, and you have your double pipes. A if A is truthy, and you have your double and signs. For B if A is truthy. And you have your bang A, or exclamation point A, which is false if A is truthy. So truthy and falsy, if you haven't heard those before, truthy and falsy are the results of the expression being evaluated in a Boolean context. So whether it is evaluated to true or false. We have our arithmetic operators, the common ones that we are all familiar with. We have addition, subtraction, multiplication. Here you can see the asterisk is used as a multiplication symbol, and we have our division. We also the division symbol takes you to a float, so to a floating point number. However, if you were looking for just a strict integer, then you would use div. And with that function, that takes two arguments. You have div a and b, your two arguments being a and b, and you would get an integer. Same thing with remainder or rem. You have the remainder, and something to look at is that the result will have the same sign as the function's first argument. So let's take a look at that. Alright, so let's go ahead and hop back into IEX, or Interactive Elixir, to review the arithmetic operators. So just as you would expect, if you were to do 5 plus 2, you'd have 7. If you did 7 minus 3, you'd have 4. And of course, 3 times 7 gives you 21. Now let's look at the division. So if we did 30 divided by 5, notice you get a float number, or a floating point number there, which is 6.0. If you wanted to get just the strict integer and not the floating point number, we would do 30 and what was it, 5? We would do 5. And there you can see you don't get a floating point number back, but you do get the integer back. So it really comes down to what you are expecting to get out of the equation, or what you are trying to do, what processes you are trying to do within your application or your system. So for an example, if we had 10 divided by 3, of course we have 3.3 repeating, but if we did div 10, 3, and put the two arguments in there, we just get the integer 3 back. So let's look at one last thing here. Let's go ahead and look at remainder. So here we have rem, and just as I had talked about earlier, the result you will get the same symbol, or the same type of number returned as the same argument. So here we have a negative 10 as our first argument, and see you have a negative 1. If we did the same thing and we switch it to a negative 3, you can see that we end up getting 1 back. Alright, so let's go ahead and move on to join operators. The join operator concatenates or joins two items. You can also subtract or remove items. But for instance, so you can see that the less than equal, or less than, not less than equal then, the less than greater than symbols, that is used to concatenate strings. And you're not restricted to just 2 strings either. And then for lists, we would concatenate those with double plus signs. And then to return elements in list 1 and not in list 2, so to remove elements from the list, we would use the minus symbols, double minuses. So let's go ahead and take a look at those real quick. Okay, so let's hop back into IEX, and let's concatenate a couple strings. So just like you do with every new programming language you learn, you always do hello world. I think it is a rite of passage. So as you can see, I put a space after the O in hello world so that we wouldn't have one big long string, but I use the less than and greater than symbols in order to concatenate these. See? So you can see that we have hello world now. Now, just to show you that it's not, you're not restricted to only doing 2 strings. You can do multiple strings. And we will show that now by going ahead and concatenating 3 strings there. So we had the 3 strings of what and is and going on, and we just made 1. So now if we were going to concatenate some lists, let's say we had 1, 2, 1, 2, 3, right? And we do our double pluses, and then we add 4, 5, and 6. And you can see we now have a third list of the 2 lists added together of 1, 2, 3, 4, 5, 6. Now, of course, a list isn't restricted to just numbers. You can have multiple things in there. multiple different types. So let's put in a JT, a string. We'll put in an atom. We'll put in a number. And then we'll add another list. We'll concatenate it to another list. And this one we'll just do 4, 5, and 6. And let's do one more, in which we have third list is here. So we'll do 6, and let's do 9. Oh, we put in. Alright, so let's finish this up with the in operator. So in is great for finding out if something is within something. So, just as it sounds like, the word in. So in this example we have n in range. So it tests to see if n is included in the range. So let's open up IEX and take a quick look at that. Alright, so let's take a look at the in operator now. So we'll go back into IEX, into our command line, and we're going to test to see if n is within a range. So we'll create a range. Let's call it range. We'll say range equals, and we'll do 3 dot dot 9. So the dot dot equals helps you to create the range, or it creates the range. So as you can see, the range is 3 to 9. So we'll see if 4 is within that range. You can see that's true. All right, let's try 6 in range. That's true. Now let's pull up something that would be outside of that range. 10 is false. And let's go the other way. Let's say 1 in range. You can see that is false as well. So as you can see, this operator is good for finding out the status or placement of an element. Thanks for joining me to review the Elixir operators. Together, we can code the future. See you next time on TechBytes.io.